Hello, everybody. Welcome back to the lunch session live stream, our Elastic Live user group. I am your host, Jay Miller. Apparently, one of our guests has a motorcycle behind them, but that's okay. I'm happy to have with me two wonderful guests from the Elastic team to talk about a topic that I was not all too familiar with until we started planning this. And now I feel like I still don't know all that much about it, but at least I could do a little bit better in explaining it. My guests are Josh and George. Folks, how's it going?
Doing well, thanks. How you doing?
Doing pretty good. What about you, George? I think you're still muted. So maybe that motorcycle's still happening. So we're going to assume that that's the thing.
That's me. And, of course.
All right. Well, I'm going to let George figure that out, and then we will just kind of go in. But we are talking about index lifecycle management this week. And Josh, let's just kick it off with a very good introduction. What is index lifecycle management, or ILM?
Sure. Thanks for that introduction. So real quick, let me kind of tell you who I am really quick. I'm one of the support engineers here at Elastic. I've been here for a couple of years. Was a customer before that, so I've really developed a love for the Elastic products, and very happy to be able to come here and share that with you. Really quick, the ILM is Elastic is built on indexes, built on very small pieces of data. Saved into larger pieces, which finally join into an index. The ILM is a policy for moving these indices around to different nodes with different retention periods. So you keep data that you need on hotter nodes, what we call hot nodes, but it is also more performant nodes, so that you gain that performance when you're writing and reading from the data. As it's no longer needed, it can move to lesser performant nodes, warm nodes, cold nodes. You don't search it as much. It's no longer being written to. You don't really need the performance there, so it just moves along. And then finally, you go to the delete phase if the data is no longer needed. So it's just really a policy to keep your data as long as you find it relevant to what you need.
So. Yeah, and just to add what Josh said, quickly when you first start Elasticsearch, if you're playing around with it or you're kind of evaluating or just, hey, curious about it, you'll quickly realize once you set up Elasticsearch, you get data ingested, and then you start to look at Kibana and view this data. You'll quickly realize, like, hey, maybe you leave it for maybe a week, or maybe you leave it for longer, and then quickly you run out of disk, right? So and you're like, hey, my dashboards aren't working, or I'm not able to ingest data. What's going on? And that's just typical, because I think when we talk about the life cycle of data, or having data in Elasticsearch, you kind of have an idea of how that data is going to be managed, how it's going to flow, and then yeah, as Josh was saying, how are you going to match kind of like the assets, the value of your data with your assets, because as Josh said, if you're looking at very the data that's just ingesting for like observability, the first data that arrives onto the cluster, you want to if it's an alert or if it's an issue, you want to be alerted right away. And that's why you want to have the most performant nodes, SSD drives, a good amount of CPU and memory, to be able to drive that. And of course, as data ages, then it becomes less searched and thus less valuable. So then you want to match those resources, the value of that data with those resources. So you want to traditionally go to like a warm architecture. Something that might be, warm, something that might be SSD front cached, or maybe even spitting disks. And again, as the data continues to age even further, where it's maybe read-only data or data that you need to keep for regulatory reasons, or let's say, hey, in case of a security breach, and this is, of course, for the enterprise standpoint, you might want to keep that data for 18 months. And then how then do you assess that, given that value of that data, how do you align those resources there? Yeah, so data management in itself, or the index lifecycle management, is all about that. And of course, it has a story on how long it's kind of, that journey that we've done in the data lifecycle management.
So one of the things that I think what made it hard for me to wrap my head around this so much was I tend to work with finite data sets. So, I take a CSV file, or I take a series of CSV files as it's becoming more and more for me, and I'm uploading them and I'm uploading them. I'm doing that like one time, and then I'm having to work with, 8 million, 10 million records from, 6 or 7 CSV files. And then I think it finally clicked once I implemented like a Logstash solution, or once I implemented like Beats, and it was like, 10 million, that's nothing. That's just gigabytes. And what we're talking about is being able to effectively scale this system to where you have, terabytes of data, billions and billions of records. How soon should you be thinking about, hey, this is going to be an ILM kind of thing I need to be worried about? Or is there never, a time you just started out, always do ILM, always have that policy?
Well, so ideally we would like everybody to start with that thought in mind. But when I first started playing with Elastic and started spinning up clusters, one of the first things I read was, your first cluster is just going to be terrible. It's going to suck. People don't know the intricacies and how to structure this data. So just go in with that mind, where you're gonna learn through iteration. You're gonna just keep putting on another cluster. You're gonna learn from your mistakes. You're gonna implement ILM, be able to save your data for longer periods of time, and then remove it over time. But ideally, we would like people to start thinking about these questions before they put up a cluster. If you look for what could potentially come in, build your ILM for the best case scenario. So you're going to have a lot of data. You want to keep it for a long period of time, because ideally, it's not, if you need it and you don't have it, you've wasted all that time. So
I think Winston Churchill said that hope is not a strategy. And I think what I mean by that is, I think it's all the best intentions, right? I think if you get a chance to play, learn, kind of explore and understand that. And then from my comment earlier, usually the first kind of pitfall is, oh, my data is full, or my disk is full, like if it's on a container, like whatever you're running it on. So I mean, you quickly realize, oh, I need to manage this data. So hopefully, if you haven't tried our stack yet, or Elasticsearch yet, we can say, hey, start to think about what are some of those things that I want to start off with. Traditionally we see, and again, I think I'll ask you, Josh, because you work with customers and our users. But what I personally see when I speak to people is 7 days is kind of like the where the data will arrive in your hot nodes. And you may not have. It really depends, because I'm sure the audience here that's listening to this, they could be very varied, right? It could be from someone that wants to play with the software to kind of learning, get more, and then maybe there's some people here that are very experienced and are maybe a part of enterprise looking to implement this. So regardless of your range, you can start thinking to yourself, well, I've got about X amount of data, and I want to think about how much data that I'm ingesting. And I can start thinking about, okay, well, and then the value of that data, how long do I want to keep that data in retention for before I ultimately, can I delete it? Can I save it?
Right.
What can I do? So generally, and one thing that we'll kind of show, as we're kind of talking along is, we have, as Josh was talking about, ILM policies. We can kind of show that within Kibana and also in our Elastic Cloud. But you have flexibility of really defining what that is. So to your question, Jay, in a long roundabout way, is I would start thinking about how, what are you trying to accomplish? If you just want to evaluate it, keep it maybe for 7 days. Like if you think about how much data you're ingesting, or look at it and figure out how much disk space you are, and then just set the next phase as delete. You don't need it. But as you continue on with your experience and growing, then you'll understand, okay, yeah, I need to then move this, and then how do we do that? We'll actually kind of talk about some of that in TCO type piece as well.
So it definitely sounds like it's one of those questions you should be asking when you're about to undergo a new project. And by the way, speaking of questions, this is an AMA. So I do want to throw it out there to the folks watching on the live stream. If you have questions, put them in the comments, put them in the chat. I can't promise we'll answer every single use case here, because we all know every use case gets answered with "it depends." But if you do have some of those "it depends" type questions, we do have a great discuss channel that you can go head up to. And maybe we have some other videos that show some examples similar to your situation. And you can do that on this YouTube channel. Make sure you subscribe. And then also make sure you're connected with our community over at community.elastic.co. But I will say, kind of riffing on that same idea of questions, a lot of my friends are like consultants. So they're the kind of people that they make it their job to say, hey, company, acme.co says, I want to build this new architecture. I need to build this new infrastructure. How hard is it to implement from scratch versus going back and like trying to retrofit this existing, infrastructure with ILM?
How hard is it to go back? So you already have the infrastructure in place. You've already got your Elasticsearch data there. So if it's already built properly and you already have it sized, you can obviously add, or sorry, not obviously, but you can add policies to your cluster and then apply those policies to your indexes. So it's really a simple move from infrastructure that's already in place to start adopting the ILM policies.
And to add to that, usually those consulting conversations, I always like to, when I'm in a consulting type role, I like to answer questions with questions just to make sure that I have the whole scope, right? Because in talking with a lot of customers, I think the idea of how much data the retention is an open-ended question, because it's going to really depend across industries, across use cases. Depends if you're just playing with it or you're actually implementing it. So the one thing that I like to bring up and talk with other folks are, okay, let's kind of ask the business itself. Okay, let's just say it's security data, and we're gathering data on metrics, logs, security event data, maybe some other telemetry data that's really kind of builds out your data that's going to support your SIM or security use case. And you kind of ask the business if for whatever reason that we need to go back to this data for security investigations, what are we going to how much data we need to keep. And if having those conversations with your stakeholders really get an idea of well, legally we need to be able to search this data or for an X amount of time. I think a lot of the industry, a lot of just based off of what other vendors' limitations are, I see a lot of people saying, hey, 90 days, because that's all what they can hold and they're able and capable for. For all intents and purposes, Elasticsearch will scale, way beyond the terabytes and petabytes worth of data. It's just matching, again, those resources and how valuable that data is and how readily available that data needs to be. So obviously, looking at your retention period, and of course that's me, my next door neighbor has just decided to do some construction right now. But anyway, and of course, hey, this is going to be the thing about consulting, right? Is unexpected things that come up, right? Maybe the business has, we want to keep a year's worth of data. Well, obviously, if you keep that all in SSD storage and hot nodes, that's just economically unfeasible. So how do you match that data? How do you get that data to match those assets? And we'll kind of go into that a little bit. But I think having those real conversations with how much data we need to have, and then say, okay, what is our budget kind of based off of that? What am I actually allocated? Because then from the business gives you the requirements, and then at least you'll be able to match. Okay, that means I can keep this data here for a certain period of time, and then transition out. So hopefully that kind of gives a little more clarity on having those conversations. I think first initially, just with your stakeholders and asking like, what do I actually need, and how long do I need to keep it for?
One of the things that I kind of thought about as you were saying that was also the idea of what it means to retain data. Like, I think that there's a lot of, you see these security breaches that happen because someone's like, we have the last 50 years worth of data stored inside of this database that no one is querying, except for like the few times where you need to find it, those few times you need to archive a thing. I feel like what this does is it almost gives you a good reason to say, hey, this stuff doesn't always need to be like accessible right then and there. And I think that can be a part of your strategy too, of like, what's the natural life cycle of this data? How long am I going to need it for this moment in 90% of the use cases that I have? And then the 10% that I do have, let's look at, viewing and reviewing that data in another format, or maybe bringing it, saving it as a snapshot, and then like maybe just loading that snapshot and running with it then and there, versus always having it available, which then of course makes, any type of data, intrusion that may happen, because it happens, we have to acknowledge that it does happen. We can at least prevent all of the data from being collected at once.
Right.
Actually, Josh, I had a question for you, and we were kind of talking about this, and you haven't got a chance to answer this quite yet, but I mean, from the customers you speak with, what are some of the retention type, the customers you talk with, what's the retention period that you see? I mean, kind of like the min-max.
So as with everything, that really depends. So
you've already done it.
It depends on the data type. It depends on policy. It really depends on what their use case is. Majority of them, like you said, is hot 7 days. I mean, that's pretty much industry wide. Everybody wants 7 days data quickly. From there, like I said, it depends on what type of data you have. You have web logs, you have metrics. Metrics you're not really going to need beyond the first few days. So those are going to be gone. They're unusable. Web logs, though, that one, when I was a customer, we would want to keep those year over year, because we want to be able to see the busy season the previous year and compare that to this year. So some of those questions are what you need to go back to your customers with and find out what you need. So 7 days hot, 30 days warm, 90 days cold and frozen. But in my case, it was year over year. So it was 18 months frozen. So
wow.
That it's gone. But the problem there was we didn't have the frozen tier at the moment. So it was trying to roll up, trying to save space as much as you could.
So we've kicked out some terminology. I want us to give a quick definition of this for those that are just getting into the space. What is hot versus warm versus cold versus ELSA, as I call it?
Yeah. So the hot is the newest data that is being written to. It has replicas. You want to be able to write as fast as possible and query as fast as possible. So that goes on to your most performant nodes. It has a lot of RAM for your heap. It has SSDs for the storage. It just performs as fast as possible.
And typically, just to match that, it's the most value in terms of like security or observability use cases. Mm-hmm. Typically, that's the most valuable data that you need.
Yeah.
So Elasticsearch, we're in near real time. Mm-hmm. And what I mean by that is, there is going to be a delay. And really that delay is in a lot of ways configurable, but I mean, down to the second when that data is on the cache, mm-hmm. and it's ready to be searchable. So it is near real time. So, I mean, if you are receiving, if you're seeing high CPU, like on the metric side, or you're receiving an error message that you feel is critical, and you have alerts that you can configure inside, Kibana on, then you want to know that as soon as possible if you're just doing observability or even security. There's a weird event that's, there's some correlation there that I'm getting some details on.
Mm-hmm.
Let's say there's on access to a resource from an unknown IP address that has never been there. I mean, those are some of these actions that you want to be alerted to right away. Mm-hmm. So having that data, like for example, on what Josh said, is critically important.
Yeah.
It's the value of that data.
Yeah, and I think you really want to take the time to plan out your hot data, your hot infrastructure as much as possible, because it's also the most visible if it's not planned out well.
It's also the most expensive in most cases as well.
It is definitely by far, yeah. So that's the hot. Warm is very similar to hot. It's still very performant, but it is no longer being written to. So you've gone hot for 7 days. Once you're no longer writing to that data, you move it to warm. So you can still have replication for the read throughput, but you're no longer writing to it. So it doesn't have to be as performant. You can gain some read performance if you add replicas and whatnot. So it's not as expensive. It's not as big of an issue if it's a little bit slower. So it's not as visible.
And there's a lot of
really quick, George. We have a good question in chat, and I'm gonna throw it up here. Can we define the ILM that the data landing starts in warm rather than hot? I'm interested in this because I do often wonder when it comes to hot. That's like, I feel like that's almost like, app data. I want that to be so responsive that, the people that are searching on a Yelp-like app where they're looking for location data, they're looking for stuff, you can just move things into where they are based on their recency, versus stuff that gets added may not be required right then and there. So maybe it is like, I'm adding this to add it. We can move it to hot when we need to move it.
Yeah.
And one thing, because I think Vikram, and my apologies if I mispronounced your name, but if you're self-managing Elasticsearch, so you have it installed on a laptop or server or whatever, you really have the ability to choose what's the hardware profile for hot. So even though when Jay, Josh, and I are talking about hot, let's say that, hey, I don't have the budget, or the use case doesn't really call for having SSD drives. Maybe my hot, on our definition, it's kind of an abstract definition, maybe disks that would be like spinning disks, or maybe disks that are less performant, or not as much CPU and memory, right? So when we say hot, this is kind of what we've seen in experience when we're looking at like maybe some larger enterprises. But let's say for budgetary reasons or just for use case reasons, your hot, or as the data comes in, could be whatever you want for the underlying hardware. Or even if you're using like, in Google instances, EC2 instances in Amazon or Azure or whatever, you can decide what type of instances that you want to have that will be your hot. Now, we kind of talked about warm, and we haven't really talked about that cold and frozen, which really kind of definitely adds more of the reduction in the total cost, the TCO, that really can help out. And that kind of comes in the territory of like some licensing stuff. So we want to be upfront when we talk about some of that, because some of it is just paid features. But again, I think kind of understanding the full breadth, or some understanding around that, and then also introducing some other concepts that are still be your, open and free and open terminology. But we can kind of discover some of that.
You mentioned TCO. I'm guessing that's total cost of operation.
That is correct. It's not tops, chickens, and
nope. Don't confuse them.
Nope.
No, but I think that is a good point. Is there's a lot of, as Ricardo mentioned, hot it just means most access. It means it's the thing that's up and running. It's in your face and it's always there. I do wonder though, because Josh, you mentioned warm is a lot like hot, except for it's no longer being written to. It's kind of that read-only state. So could warm be the most frequently accessed, and hot, not be that space?
So I think what you're talking about is a different form. So we're getting more into the data tiering. When you're talking about warm, you're trying to move it over to a different node. This is with ILM, the warm is never written to. So, but it's just a policy, but it just tells it where to go. So, okay. But then we have, below that, it uses some of the settings in the hosts to define where you can move your data, which is, I believe, more about where this question is. We want to move the data over to the warm nodes first. instead of the hot nodes.
Okay.
Yeah, and I think hot and warm is a industry term in a lot of ways. I think hot is synonymous with expensive, most accessed. Yeah, very expensive. Whereas warm is, traditionally a step down, not as accessed as frequently. Like I think what Ricardo had said is accurate. It's just not as accessed as frequently. And then cold or even frozen, it's less. And then you could almost think about performance also under that same type of temperature gradient. But again, we're in conversations with some customers that just want to do hot, and then after 7 days they want to still keep the data, maybe for regulatory reasons or whatever, so that data can go directly to cold. So you don't have to go through all the temperature gradients from hot, warm, cold, and frozen. You can go hot directly to frozen, and there's some and that will help also reduce greatly the TCO. Because if the warm nodes, for example, they keep some of the replica data, that data on the nodes themselves, but I mean, you might not need that. So there's a lot of different options, and kind of really thinking about your use case there. And really, if I got a fixed budget, like all of us will have, what is my budget? Oh, I can keep more data if I just do 7 hot, and then let's say 18 months on frozen. And I know that maybe there might be a slight performance hit. But still, it's okay, because it's going to be a lot quicker for me to do than just like take a snapshot and then restore from backup. So there's a lot of these questions on accessing the data and when you need it and when you need to search it.
Yeah, and I probably need to backtrack a little bit on something I said. You can still write in the warm nodes, but it's just not as common. You try to keep the writes off of there and updates off of there. You want to do that on.
Yeah, and opposed to cold and frozen are specifically read only as well. So it's kind of one of those things where, so and here's another conversation too that we really haven't come to the subject on is we also have where customers and users will focus on how fast they can index data, or ingest data into Elasticsearch. So they may have nodes specific just for how fast can they ingest data, and they have some other nodes that are just focused on how fast can you search the data. And I think when you look at Elasticsearch, there are a lot of these tuning knobs. Like it's almost like if it's a Boeing 737 cockpit, you might turn here and there. But we've got a lot of great guides on kind of best practices for fast ingest speeds versus fast search speeds. But generally we're kind of, when we say hot, at least I'm specifically looping the indexing and search all kind of within this hot category. So
okay, yeah, and we've still got kind of those two areas to look at too. So let's jump into like cold, and I love that George even mentioned before that like once upon a time Frozen wasn't a thing, and I don't mean the Disney movie. Like let's figure out what cold's role is in this realm of hot and warm, and we kind of know what they're doing, and now cold, where's that at?
Yeah, and I think it's so for the people that can't let it go, they can't let data go, like Frozen, right?
No.
Yeah, I got it in there. There's the cold. So I'm going to put in hopefully this is not going to conflate what we're talking about. But I think it's very important, because to the people that we're speaking to, either you are using Elasticsearch, the open source or free, open and free, or you're licensed and so forth. There's ways that you could do when we talk about cold in kind of two different contexts. One way, obviously, is the free and open. You can use with a basic licensing. You can use data tiers to move your data using ILM, Index Lifecycle Management, to move from hot to warm to cold. And you, as a user of the software, you've defined cold as your maybe from SSD. Let's say you have spinning disks, something that is just you're going to take a hit on your query performance because those disks, the hardware is not as performant. So you could do that today. You can define your hardware profile in cold to be that. That's kind of like the abstract way. Now there is a feature it's a licensed feature, so this kind of comes into the realms of this is something that you would purchase from us. That where if you're using what's called searchable snapshots, will allow you to search snapshots that you have taken. So traditionally, snapshots were used for if you wanted to back up your data or data that you wanted to archive, and then maybe you wanted to restore later to search. So there's a lot of solutions out there. Like if I know that I'm searching my data for the first 7 days, and then after that, I want to archive, let's say on a object storage like S3, or maybe a Minio, like a S3 compliant storage device that's locally. You could do that, and then you can say, hey, I know this data is approximately a month ago. I'm going to restore my data from Snapshot and kind of rehydrate that into my cluster, and then I'll be able to search that data. But searchable snapshots, and it works with the ILM, or moving that data into that, allows you to search your snapshots without you rehydrating the data. So basically what it does is it kind of decouples storage from compute. So traditionally Elasticsearch, when you install a node, it's the storage is attached, and then you use the storage of the local storage there to run. But by decoupling the compute and storage, then you can start looking at different storage tiering options, like for example S3. So the cold allows you to keep the primary shards, which is the primary data shards, is used for search, but the replica shards it also could be used for search. But in this case, when we use cold, the replica shards are now sitting on S3, backed up on snapshots. So if there's if there's a issue with the data, you could restore that particular replica data into your primary shards, and you won't lose any data. And by the cold data, by using this license feature, you're able to store a lot more data at the same cost as your normal data, because instead of storing your replica and primary shards together, you're only storing your primary shards on local data, on local storage. And then you have your replica data on S3, much lower cost options. So with cold, you could think about, and this is only read-only data, so data that you're not going to change and modify and move around. So the cold data tier using searchable snapshots really reduces your TCO, because you're able to search and store twice the amount of data as what you normally would do. And then there's a lower tier, and before I go that, I'll make sure if you have any questions, Jade, or maybe kind of get it from the audience, but even there's there's even a further tier called frozen, which we can kind of talk about as well. But that cold tier itself, gives a lot of opportunities to say, hey, I still want to have some, very performant, my data is on local storage. It's going to be very fast, but I still want to have my data being replicated or being protected. And I'll have that replica data stored on lower cost storage. So hopefully that kind of makes sense.
Yeah.
Sure. Josh, you have anything
to throw on it? Yeah, and also on top of that, we have engineered this though to still be very performant. So it might sound like it's going to be slower, but it is still a very performant search. So it's going to be, it's still going to return your results almost as quick as warm. So it's really a benefit for the customers that use this, because they, like George was saying, you can get a much higher index to RAM or storage to RAM ratio going from warm to cold. So it is a huge benefit for the customers.
Okay, and then you mentioned, George, there is that last part, that frozen tier, and my guess is as warm is to hot is frozen to cold. Is that it? Or I see the face now where it depends is going to come out of someone's mouth. Okay.
Actually, it's actually, I'm really surprised with. Okay, so let me talk about frozen and some of the performance around frozen, because we're not robbing Peter to pay Paul. We're not just giving you S3 storage to be able to search on. just so that you're, throwing, we're storing this data on really low cost storage, but then it costs you in terms of search performance, because I think that's kind of the thing there. I mean, you can expect latency and maybe some slower search queries, but when you kind of understanding the underlying technology, I think that it's really beneficial. So frozen tier, is we're again decoupling storage from compute, and then also again it is a licensed feature. So we're talking about things that you need to pay for. But the frozen tier aspect is we're storing all of that data in a snapshot that resides on object storage, like Google Cloud Storage or Amazon's S3 storage. And we're able to, we've done some work on the underlying Lucene, which Elasticsearch is built on, to provide, we're only going to search for what is going to complete the query based on the S3. And then also we've built in a search cache into Elasticsearch. So now a percentage of the memory used for, is used on the host is dedicated for a search cache. It's a search cache mechanism. So, let's say you want to search a petabyte worth of data. Well, whereas the first result might take a lot longer, those results are going to be cached into this query cache, this system cache. Well, it's not a system cache, but it's a cache for the searchable snapshots. And next time when you search for that, the performance is going to be greatly improved. So, for example, there's a blog article that's out there, and maybe if we, I can find that in just a second and put it into the comments. But it's searching a petabyte of data in minutes. And I mean minutes is even when we query the first time, looking through a petabyte of data stored on S3, and we're using the underlying Lucene modifications and enhancements we've done, we're only searching for the things that we need. We're able to search a petabyte worth of data in 9 minutes. And of course, once you search it again, we drop from minutes to seconds. So I think I have a slide on this I could probably show. Let me see if I can try to find it real quick, because I think we've been kind of talking a lot, which is great. But there's this great, let's see if I can try to find it real quick.
So while he's doing that, I see we have some comments thrown in here that are very specific instances. I think that obviously, we'd love to help, as much as we can. However, on this stream, it probably wouldn't be the best type of support. But again, a good way to handle that is heading over to our Discuss forum there, asking your question. You have plenty of people, including elasticians, that are observing that and will hopefully get you to a good response. But go ahead, George. Let's see what you've
yeah, and I think we could definitely take a look at some of those questions. Of course, I just share my screen. So let me know if you can see some of the performance information here on frozen tier sizing.
Yep.
I'm just going to do this here. What I really wanted to focus on was kind of some of the performance there. Now, the blog really goes into great detail of our methodology and how we tested and sized. So then there's no, don't look behind the curtain, the man in the curtain or whatever. So we're definitely transparent on how we're doing a lot of the sizing and so forth. But yeah, we look at a simple term query on a 4 terabyte data set. When we do it, we're looking at kind of this hot, warm, cold, frozen type of architecture. The hot and warm, you can expect your first run on a term query to be on 4 terabytes to be around 92 milliseconds. And on cold, you see that there's not much of a difference. We run that cold again, that primary data that we're searching across, that sits still on local storage. But we also use the primary, replica shards also in our searches or queries. So that's why you see still a better performance with hot and warm, because we're not only searching the primary shards, but also the replicas. But now because the cold in the cold tier, the replicas are stored on S3 storage. We're not searching that. We're just searching the primary shard. That's why we do see a slight decrease in performance. We see like 95 milliseconds here. But again, I mean, if you think about, that's fine. I'm willing to take a couple milliseconds more, knowing that I can store 2 times the amount of data. You know, given if you have one replica and one primary shard, I can still store a lot more data on my primary with just a trade-off in performance, and it's not by much.
Yeah.
But when we look at frozen, you know, if we do, you know, the first time we're doing a 4 terabyte data set, we see 6 seconds. But on a repeat run, we can kind of see now that some of this data is loaded into cache. Hot and warm runs quicker at 29 milliseconds. Cold runs at 38 milliseconds. But frozen, we see a great, huge improvement in performance, down to 76 milliseconds. So if you kind of take a second to stop, if you're looking through security data, let's say you're looking through, you've identified the IP address of an adversary, and then now you want to look at what's the first time I see this IP address amongst my security data or my observability data. That I can look for that IP address across all that data. And if I need to reference that IP address again, those subsequent queries are going to be much faster. So that's kind of one of those benefits where the first time you query, it's going to be slow, but that's okay, because you know what we're doing here on this next orange line is when you restore from a snapshot, it's, you know, the same 4 terabytes that's in a snapshot. You're restoring to the cluster. It's going to take you about 1 hour and 12 minutes for you to be able to restore and then put that within a cluster and then be able to search it. Now
and to clarify there, that is you have a snapshot, you're restoring that snapshot and you're loading it. This isn't if you're using something like searchable snapshots where
that's correct. Yeah, and I think it's important to note, because if you are using our open source or just our basic, you know, licensing, so you're not paying, this is a completely acceptable method for you to be able to archive your data without any licensing costs, right? So if you're restoring, you know, if you have a good system, a catalog system where you are, after your, you know, 7 days of, let's say, hot, and then you automatically want to archive your data and keep that data on very low cost storage, that's an absolute thing that you could do. You just know that it's going to take, you know, 72 minutes per snapshot, you know, to be able to restore and get that going. That might be completely acceptable to you and to your leadership, you know, your business leadership, right? But the ability of having, let's say, to be able to search it, you know, is great. So I mean, if we look at scaling up to a petabyte, and we just looked at frozen, right? On the first run, it took us 9 minutes to do searching a petabyte of data stored on S3, and the repeat runs is 2 minutes. So I mean, it's orders of magnitude greater performance when you're looking at using that searchable snapshot on frozen tier. So
I think another part of that as well is, you know, we're looking here 4 terabytes versus 1 petabyte. Oh, sorry about that. But if we're thinking about looking at hot and warm and even cold, like one of the reasons we talk about ILM, there are performance reasons to remove the cruft. If you're looking for something and it's going to have to search everything no matter what. So if it has to search everything, make everything less, and you can move all of that stuff somewhere else where it's easier on the system to find it. So if you have a petabyte of data, it's better for you to keep 4 terabytes of that petabyte of data in hot and warm, and then move the rest of it over to frozen. And then you don't have to say, well, how come every time I'm running something and it's in hot, it's going to be slower than 92 milliseconds. So just the idea of managing your data in this method has its own performance benefits as well.
Yeah, and Josh, I think you probably have some insight into when you have data. You know, and I think, Jay, what you're talking about is you know, Elasticsearch is very fast and it's very, you know, it's a search engine, it's very performant. But there are ways to make it a lot quicker, right? And we're insinuating that, you know, based upon what data that you commonly search, you know, you could reduce that footprint to be able to get the best search results. I mean, when I was in support, and Josh, I'm sure you have a story as well, but we would have customers say, hey, I'm ingesting all my email, and I want to be able to do a full text search on all my emails. And some customers wanted to search every email from the beginning of time. And that data set is just massive. And sometimes as an administrator or someone running the cluster, you kind of have to put guardrails so you don't bring your cluster to its knees.
Yeah.
Josh, do you have any thoughts on that?
Oh yeah, you always have to set the expectation. You need to structure your data when it's coming in, because it is very easy to cause more harm than what you're trying to build. So yeah, that's why we have the templating. That's why we have testing. It's just, you need to do the upfront work to make sure that you're not going to harm yourself with bringing in this data. And then I'm not sure if we should talk about new features. We also have like data streams, which helps query fast. It helps you write fast. So we are always innovating these new technologies to help you be as performant as possible, because we are getting so much data now, or the customers are putting in so much data that we have to stay up with new technology and provide this new technology to be able to write and read fast. So
sounds like we're going to have to bring one or both of y'all back to talk about data streams too.
Yes.
But I definitely do agree that, in some cases we're talking about support. I used to be in IT, and I can tell you, I would much rather have the one support ticket, every year or so that says, hey, I'm trying to find this email from 20 years ago. How can you help me? Versus having the constant email, support tickets of, search is slow, or this isn't finding, or there's a bunch of junk in here I don't need. And I will say, I'm pretty sure we get more tickets of the latter, because the first time someone doesn't have, the most amazing of experiences, they're willing to shout. We've talked a little bit about, these different tiers. I know we kind of scheduled this out for an hour, so I want to make sure we have some space for questions if there are more questions. But then also, how do we set this up? Like, how do we get started with these data tiers? I know data tiers are kind of like one piece of the whole ILM picture, but I do think it's a great place where people who may be looking to implement this for the first time, or maybe looking to go to their boss and say, hey, look, this is a thing that could give us some, some cost benefits, some performance benefits. They're going to want to be able to flip a switch and show how easy it is. So I guess the first question is it that easy to just flip a switch on data tiers?
Yeah, I think so. So shameless plug, I think Josh and I and Faith, we had was a meetup some months ago. And Josh did a great job of showing what if you have an existing Elasticsearch cluster, how you're to introduce ILM. So I think that's a great video to kind of go back and watch. You might want to skip over the first couple of minutes, because I think we kind of do introduction about what is Elastic, and great if you don't need that. But even since when we had this talk, when Josh and I did this. There's a lot of advancements, like in searchable snapshots, for example. It's not something that him and I were able to talk about at the time, but in that time, once we had that, we have all this. So we know the pace of innovation at Elastic is crazy. Even internally as customers, or internally as employees, we're like, okay, what do we release? That's crazy. Like, how does that change the conversation of data management? But I do want to show, this is inside our Elastic Cloud, but you have the same experience if you're deploying Elasticsearch in Kibana. Let me go ahead and go back to my screen here, and let me know if you can see this.
You're all good.
Perfect. And so what I'm looking at is just kind of like the home screen for Kibana. This happens to be, I have a deployed Kibana. It's Kibana on our Elastic Cloud, but again, you'll have a very good, similar experience within a managed, self-managed Kibana. But if I come over here to kind of our menu items on the upper left-hand corner, you'll see something towards the bottom that's called stack management. So Kibana is not only used for is the window into your data to be able to visualize and explore and analyze that data, but it's also for stack management. Now, all of this can easily be completed as well through APIs and through the dev console, which I think Josh definitely goes into. But the simplicity side of getting started, I think it'd be great just to kind of go through Kibana and look through it. But down here, you'll see where we have index lifecycle policies. So if I go into that under data, then we can start creating our policy. And there's also some policies that we put in here that's kind of a basic, our system indices and how we manage and create that. But if I create a new policy, I'm going to call it, let's say data management. And then maybe I'll say it's test because I'll know to delete it later. But if we kind of look through this is a great UI that the Elasticsearch and Kibana UI team worked on that kind of walks through each of these phases and gives you some of these options. For example, in the hot phase, we have some different options. Like, do you want to roll over your data from the current index? And then, there's a rollover where it takes it from one of your hot nodes and then roll it over into a lower tier or lower phase index. And then do we want to do, let's call it a force merge? Jay, do you want to briefly talk about like what a force merge and a shrink are?
Let's hit it really quick. If we can.
Sure. Oh yes, on the time.
Oh, you're asking me to do it.
Oh no. I said Jay. I meant Josh.
Oh,
hey,
sorry.
I was like, I am your host. I'm here to smile and make sure chat doesn't explode.
Smile and wave. No, I'm sorry, Josh.
Yeah. So force merge, really quick. The quick overview of it is as you're writing events to your disk, it's almost like a fragmentation. You just write it to disk as quickly as possible. So you're going to end up with all these events all over all of your disk in segments. What a force merge does is it takes all of these segments and shrinks them down into one larger segment, and it just keeps getting smaller and smaller number of segments, larger segments though. So you end up with one large segment at the end. It's the most performant.
Yeah, I almost think about it. This might age me a little bit. When you had spinning disks, it was almost like a defrag, right? When you had to run a disk management tool in Windows.
Yeah, exactly.
I use Linux now, so don't judge. But yeah, so you're kind of reducing the amount of segments that you have. Yeah. And then shrink obviously is also if you have. We talked about primaries and replica shards. They're used to be searched. Mm-hmm. And if you could also shrink on how many of those shards that you need. Yeah. If you have the primary, you can tell how many shards Elasticsearch cluster has. You could say, the default's one primary, one replica. But let's say you have a use case for having a larger amount of primary shards, or you want to have, some extra redundancy. So you'll add extra replica shards. Well, having more shards will give you the ability to have more, threads working on a search. And of course, you can have too much shards that would negatively impact you, but a shrink is just the ability to take some of that sharding that you had and just reduce it down and shrink that down. So
I think priority also is kind of overlooked also. That's a really good one. If you have important data, if you have an issue and you have important data, you can set a higher priority on your important data so it's recovered earlier in the recovery process. So you have some really important data, you want it to recover first, you can see it first, and you set your non or less important data lower down so it's not restored or recovered as quickly.
So I can see this being something along the lines of, again, if you're just constantly pulling in data and pulling in data and pulling in data, recovering that recently pulled in data may or may not be the most important thing. There may be like some importance on historical data and making sure that that's preserved, whereas the newest data could probably just be re-imported, or you could say error has occurred, please try again, whereas data that you've kept for 3 decades, you may need that data faster and to make sure that that data is I guess sturdier.
Again, it's all based on what's important to you, so just another setting that we provide.
Yeah, absolutely. And so by looking at the advanced settings here, right now the only thing that's configured is the hot phase, and then we're going to keep data in this phase forever until you define when you want to delete it, right? But what we're going to do is we're going to say, yeah, we'll want to have searchable snapshots. So that's going to be where we're using that functionality, that license, to also use the frozen tier. But when we come down to, we can configure, for example, the warm phase. So, move this into this phase when the data has either reached, for example, days, hours, minutes, and seconds old. So, for example, we want to say when the data reaches, actually, if we can come to the top, on the warm, we say we want to have this into, let's say, 7 days. So as soon as the data is there in 7 days, then it'll move from hot then into warm. And then the warm phase, you can also have, how many replicas, allocations. There's some other priorities here you can set. And of course, if you want to set cold, same thing. You can use searchable snapshots. And then going into the advanced settings on data allocation. And then of course, finally to the frozen phase on when this can move in. But as we're configuring this, you can actually see, for example, at the very top, where you're at on how much data you have in each phase. And if we increase or decrease that kind of sets that up. One other item I'll say is, let's say after, we'll say we don't want anything that's a cold or warm. We want to go straight from hot, the hot phase directly straight into the frozen phase. You certainly can do that. But yeah, so we want to move this data, let's say, once it reaches 7 days again, and then we can kind of configure to when do we want to delete this phase. So we actually click the delete this thing and say, hey, I want to delete this data after it's reached, let's say 5 years, for example. Do I have years? No, I have days. I think they're gonna add that on later. So let's do 365. So anytime after a year, then it'll automatically delete, and that'll be that final phase. Let's say if you don't want to keep everything, and we can save that policy. And I know we kind of quickly running out of time, so that's why I'm kind of moving quickly. But it really gives you the flexibility in how you can define these policies and then move those there. And the searchable snapshot is just only going to, that's the license feature. That's going to be, it gives you the ability to do the, half the in cold, half the primary shards on local storage and replica shards on S3, or just being able to search on S3 directly. But again, for self-managed, you might still have that cold tier being the lowest of your hardware capabilities, and that kind of offsets that TCO piece.
So something else to really mention also is all of our agents have policies with them. So when you do a proper setup with it, these policies will go into your Kibana ILM policies. You can go in there and take a look and see how we set them up, and it gives you a good beginning to see how they're set. So if you're running metric beats, file beats, you do the setup, it imports it for you. So
yeah, and so if we go into metrics itself, and this is kind of based off of our experience and what we've seen our users and customers doing. So we have metrics, for example, as in the hot phase. You can go in and modify that. So we kind of come up with a template. We're more, I don't know if prescriptive is the right word, but we're definitely more opinionated on how those phases are. But it's just a guidance. You could easily go in and change those policies as you're configuring that.
Yeah.
Very cool. Well, it sounds like, as I said, you click a few buttons and you're off to the races. I'm not going to say click blindly. Give it some thought. Make sure you know what's happening, especially when you hit that delete button. But Josh, George, thank you so much for giving us a good, quick lunchtime lesson. And are y'all hanging out in the community forums as well? Is that how, if people have questions, they can get in touch with you?
Absolutely. Yep.
Yes. Go ahead, Josh. I'm sorry.
Oh, no. Yeah, I was just say community forums is one of the best places to get a hold of us. So join up there.
And I'm on the community Slack as well. So while the Slack's good for general information and some things we can help out, I'm usually on Discuss for like the larger issues and things that we'd like to solve. But yeah, the Elastic Slack channel is also a great way to get in touch with other people, like-minded people that are using the technology. So, but I think we almost ran out of time. I mean, we did run out of time. I'm always happy to talk about the data streams and some other aspects of ILM and the data tiers and searchable snapshots piece. But
well, based on some of the comments, including this one, I do think that data streams will be a thing that we have to add to our list of things to talk about. But as you can hear the bells tolling for us, I think that's the symbol to get back to work. But I want to thank again George and Josh for hanging out with us. As always, we do this every Tuesday. Different topic every time. Most of them about the Elastic Stack in some way. Not all of them, but we hope that you'll join us next time on our little lunchtime user group here. But until next time, take care, everyone.
Thank you. Take care.
thanks, Josh.
Thank you.